Exercise 14.9. Let us take the position of mass when the spring is unstressed as x is equal to 0 and the direction from left to right as the positive direction of x-axis. Give x as a function of time t for the oscillating mass if at the moment we start the stopwatch at t is equal to 0, the mass is the part A is at mean position, part B is at the maximum stressed position, and part C is at the maximum compressed position. In what way do these functions for SHM differ from each other in frequency, in amplitude, or the initial phase? Actually, this question is in continuation with the above question और above question में हमें given था a block of mass 3 kg is attached to the spring of spring constant 1200 Newton per meter and हमने उस block को एक displacement दी and that displacement is 0.02 meter. अब second question part में हमें given है suppose we have to consider this axis as plus x axis and this direction as minus x axis and this is the mean position. इस mean position के बाद about part block मेरा एक SHM perform करेगा and we have to calculate position or displacement of block as a function of time when in part A we had started the stopwatch that is t is equal to 0 at mean position. हमें पता है कि अगर कोई ऑब्जेक्ट या कोई पार्टिकल SHM परफॉर्म कर रहा है तो उसका डिस्प्लेसमेंट का एक्सप्रेशन एज ए फंक्शन ऑफ टाइम इज गिवन एज a sin of omega t plus phi, where a is amplitude which is 0.02 meter. In this case, omega is angular frequency which is under root k by m and which will be a constant quantity for a given spring and a given mass and this is phi phase. So problem A के अकॉर्डिंग t is equal to 0 पर मेरा ब्लॉक मीन पोजीशन पर था मतलब उसकी डिस्प्लेसमेंट 0 थी. So x at t is equal to 0 and which is equal to 0.02 sin 0 plus phi. So this will be equal to 0. This implies phi is equal to 0. So option A के अकॉर्डिंग जब t इक्वल टू 0 पर मेरा ब्लॉक मीन पोजीशन पर था तो उसके डिस्प्लेसमेंट का एक्सप्रेशन कुछ इस तरह से लिखा जाएगा 0.02 into sin of omega t. और पार्ट बी में गिवन है कि we have to calculate expression of displacement when the block is at maximum stressed position at t equal to 0. मतलब t equal to 0 पर displacement t equal to 0 पर maximum है, that is amplitude. So इसके अकॉर्डिंग अगर मैं स्टैंडर्ड एक्सप्रेशन में वैल्यूज पुट करूं x at t is equal to 0 is equal to 0.02 is equal to 0.02 sin of omega into 0 plus phi. So इससे ये कट जाएगा. This implies sin phi is equal to 1. This implies phi is equal to phi by 2. Therefore, इस केस में जो डिस्प्लेसमेंट का एक्सप्रेशन बना x at t is equal to 0.02 sin omega t plus pi by 2. और थर्ड केस में C पार्ट गिवन है at t is equal to 0 particle or my block is at maximum compressed position. maximum compressed position मतलब ये अपने लेफ्ट एक्सट्रीम पर होगा, मतलब at t is equal to 0 its displacement will be minus 0.02 meter. This implies minus 0.02 meter is equal to 0.02 sine of omega into 0 plus phi. So, अगर मैं फर्दर सॉल्व करूं, sine of phi is equal to minus 1. This implies phi is equal to 3 pi by 2. This implies xt is equal to 0.02 sine of omega t plus 3 pi by 2. So, अगर मैं कंपेयर करूं तीनों केसेस को, फर्स्ट केस में I got the expression in case A, I got the expression of xt is equal to 0.02 sine omega t. B case में I got xt is equal to 0.02 meter sine of omega t plus pi by 2, and in case 3 I got xt is equal to 0.02 sine of omega t plus 3 pi by 2. और इन तीनों केस में जो एक्सप्रेशन मैंने ऑब्टेन किए हैं सबका एम्पलीट्यूड इज सेम, ओमेगा इज सेम बिकॉज ओमेगा इज k by m, और एक पर्टिकुलर स्प्रिंग कांस्टेंट और मास के लिए ये वैल्यू कांस्टेंट रहेगी. बट फेज वन phases are different, means phase in option A is not equal to phase in option B is not equal to phase in option C. So we have solved the question.